My name is James Minor. Welcome to my mathematics class. In our lesson today, we are going to look at angle properties of a circle, which is a Form 2 topic. This lesson is a continuation on the last lesson where we looked at different theorems. Today we want to look at the cyclic quadrilateral. In this theorem, we find out that the opposite angles of a cyclic quadrilateral add up to 180. So we want to draw a circle so that we can show what a cyclic quadrilateral is. And then we look at an example and work it out. So we're going to draw a circle. We mark the center, can call it O, and then we are going to draw a quadrilateral, and we are going to make sure that the vertices of the quadrilateral touch the circumference of the circle. So in a cyclic quadrilateral, the vertices, that's where the edges of the quadrilateral meet, must be on the circumference of the circle. So a good example of a cyclic quadrilateral is the one I'm drawing. We have it there. Here we have a cyclic quadrilateral. The theorem says that the opposite angles of a cyclic quadrilateral will add up to 180, which means therefore that if we know the size of this angle here, let's take a value like 70 degrees. We expect the opposite angle to be the difference between 180 and 70. And therefore it's going to be 110 degrees. Now, if we knew this one, this angle, for example, let's say we have an angle like 80 degrees. It then means that this one here must be 100, so that the sum of the angles, all of them, 80 plus 110 plus 100 plus 70, will come to 360. So the theorem we are looking at today states that the opposite angles of a cyclic quadrilateral add up to 180 degrees. So that's the theorem we are looking at today, and we have shown what we are talking about here. If this angle is 70, the opposite angle is going to be 110. Opposite. If we call this P, Q, R, and S, then we see that the angle at S plus the angle at Q will always add up to 180. You can also do this in your book. You can draw a circle, then make sure you draw a quadrilateral such that the vertices are on the circumference of the circle. That is the quadrilateral that we refer to as a cyclic quadrilateral. And therefore the theorem is that opposite angles of a cyclic quadrilateral add up to 180. And now we would like to look at an example on the application of that theorem. And we draw a circle here. We draw a circle there. We have it at the center. We want to draw a cyclic quadrilateral in this circle. Okay, so we have a cyclic quadrilateral. We've said that in a cyclic quadrilateral, the vertices are on the circumference of the circle. Let's call our quadrilateral W, X, Y, Z. And so we're saying, if you are given this, we are told that this is 105 degrees, and we are also given this one. We are told that it is 65 degrees. We can find out this one. Let's call that alpha, and let's call this one theta. So our question in this case is find alpha and theta. We'll apply the theorem straight away. We know that in a cyclic quadrilateral, opposite angles add up to 180. So we apply that straight away, and therefore we can see alpha is equal to 180 minus 65, which gives us 115 degrees. So this is 115 degrees. And then we would like to get theta now. And because we have 105 here, we now ask ourselves what we need to add to 105 to get 180. Because opposite angles of a cyclic quadrilateral add up to 180, and so we can say theta is equal to 180 minus 105, and that gives us 75 degrees. So we are going to stop there for this lesson. We will be working out an example later where we bring in a number of the theorems which we have done so far. So make sure you subscribe to this channel so that when we will be doing that kind of work, you are also involved. So you need to draw this circle. Make sure you draw a particular angle. And as long as you have a cyclic quadrilateral, you can confirm with your protractor that opposite angles of a cyclic quadrilateral add up to 180. Otherwise, from me, it's goodbye until we meet in the next lesson.